Hello, hello, hello. We are going to be taking a look at some additional examples for 3.04 proportional relationships. So let's go ahead and get started. So it says match the relationship to the correct unit rate. So unit rate tells us how many times something is happening for every one occurrence. So, for instance, in this first choice, it says 410 words in 5 minutes. So, when I'm looking at this, if I'm doing 410 words in 5 minutes, in order to find out how many words I do in 1 minute, I would take that 410 and divide it by 5 minutes. So, 410 divided by 5 is 82. So when you're looking to find the unit rate of something, you take the amount that's happened and you're going to divide it by, well, how many times that occurred. So in number 2, it says 195 miles in 3 hours. So to find the unit rate, I'm going to do 195 miles over or divided by the 3 hours that happened in. So 195 divided by 3, that is going to give us, I believe, 65. So always double check your math. Yay, 65. So the unit rate here would be 65 miles per hour. So that choice would be A. And then lastly, C, it wants to know the unit rate when we have 378 gallons that's happened in 7 minutes. So we're going to take 378 gallons, divide it by the amount of minutes, and that is going to give us 54 gallons per minute. All right, so let's take this idea of unit rate and we're going to fill in this chart. So it says a printing press can print 224 newspapers in 8 minutes. Use the unit rate at which the newspapers are printed to complete the table of values for the proportional relationship. All right, so if we have 224 newspapers in 8 minutes, let's figure out how many we have in 1 minute. So I can find that unit rate like we just did by dividing. So 224 divided by 8 gives me 28 newspapers per minute. So this is the amount of newspapers in 1 minute. Well, this chart is asking us to fill in for 2 minutes. So what I'll do is I'll take my unit rate and I'm just going to multiply it by 2. So 2 times 28 gives me 56 newspapers in 2 minutes. And we're going to continue this pattern. Well, in 4 minutes, I can do 28 per minute, so 28 times 4 would give me 112 newspapers. And then in 6 minutes, well, if each minute I'm doing 28 newspapers, I take 6 and multiply it by 28. So 6 times 28 gives me 168 newspapers. Awesome job, guys. So it says, the next example, which statement is true about the graph of any proportional relationship? Okay, it is a straight line parallel to the x-axis. So if we were to graph that, that would look like this. That's not a proportional relationship. That is actually a different sort of line that we'll talk about coming up in slope in 3.03. B says it's a straight line that intersects the origin. So a straight line that intersects the origin would look like that. C says it slants upward from left to right. So upward from left to right would look like that, but that line could really be anywhere. Let me see if I can undo that. So that line, if it's just slanting upwards from left to right, could really even be up here. It doesn't necessarily have to be through the origin. It's a curved line. So a curved line could look anything like this. So is that proportional? So the answer choice we would want to say is B, because the key is that it goes through the origin. So all proportional relationships go through the origin. Key concept. All right, and the last one is the relationship represented proportional. Okay, so when you're looking at a proportional relationship, they're always in the form of y equals mx. All right, mx. This number out here, this plus 4, is actually a y-intercept. And that y-intercept moves the graph from the origin. So if we move that graph off of the origin, so if I have a graph and I draw this line and it's proportional, if I have a y-intercept, that graph will actually come off of the origin and either move up, it might move down. So if you see this plus or minus a number, that is indicating a y-intercept, which means it is not proportional. All right, guys, very good job. Hopefully that helps with 3.04.